Let's solve some mechanical energy problems. We'll go through 10 questions in this video. How much kinetic energy does a dog have running at 12 meters per second? What is the velocity of a child at the bottom of a 3.2 meter frictionless slide? Keep watching to find out. Let's look at our first question. An apple with a mass of 800 grams is raised from ground level to a height of 2.0 meters. How much work was done on the apple in joules? The first variable that we have been given is a mass of 800 grams. We need to convert this into kilograms by adding a kilo prefix. We simply divide by 10 to the power of 3, or 1000, to add the kilo prefix. 800 divided by 10 to the power of 3 is 0.8. The mass equals 0.8 kilograms. The second variable that we've been given is height. So h equals 2.0 meters. We have been asked to find the work done on the apple. The symbol for work is uppercase W, so W equals question mark in joules. In physics, work is defined as the energy that is transferred to or from an object that causes it to move. In this problem, work was performed on the apple to raise its height. The apple has had work done on it by increasing its height. When an object gains height, it gains gravitational potential energy, or E with a subscript of P, and the P stands for potential. The work done on the apple will be equal to the gravitational potential energy that the apple gains. The equation for gravitational potential energy is mass times gravity times height. Let's substitute our values into the equation. Potential energy equals 0.8 times 10 times 2.0. If we put that into the calculator, then we get an answer of 16 joules. Let's look at the second question. A 22 kilogram dog is running at 12 meters per second. How much kinetic energy does it have in kilojoules? The mass is 22 kilograms. The velocity is 12 meters per second. We have been asked to find kinetic energy, or E with a subscript of K. So EK equals question mark in joules. All objects that are in motion will have kinetic energy. The word kinetic comes from the Greek word kinesis, which means motion. Notice that we have been asked to find the answer in kilojoules. The usual unit for energy is joules. The equation for kinetic energy is half times mass times velocity squared, or half mv squared. This means that kinetic energy is proportional to the mass of an object, so if you double mass, then kinetic energy is doubled. Kinetic energy is proportional to velocity squared, so if you double velocity, kinetic energy will be quadrupled, because 2 squared is 4. Let's substitute our values into the equation. EK equals 0.5 times 22 times 12 squared. If we put that into the calculator, 0.5 times 22 times 12 squared, then we get an answer of 1584, and this will be in joules. We need to convert our answer into kilojoules, so that means adding the kilo prefix. You'll remember that we just need to divide our number by 10 to the power of 3 to add the kilo prefix. 1584 divided by 10 to the power of 3 is 1.584, and if we round that to two significant figures, the answer is 1.6 kilojoules. Question 3. The mass of a cyclist, including their bike, is 84 kilograms. They are going at a constant velocity of 18 meters per second, then pedals hard so that they double their kinetic energy. What is the new velocity of the cyclist in meters per second? Assume there is no air resistance or friction, and treat the cyclist and bike as one system. Mass, or m, is equal to 84 kilograms. Initial velocity, or VI, is equal to 18 meters per second. We know that the final kinetic energy, EK final, is equal to double their initial kinetic energy, or EK initial. So EK final is equal to 2 EK initial. We need to find the final velocity, or VF. So VF equals question mark in meters per second. The equation that we can use is the kinetic energy equation, which is EK equals half mv squared. First, we must find the initial kinetic energy of the cyclist and bike. EK initial equals 0.5 times 84 times 18 squared. If we put that into the calculator, then we get 13,608 joules. We will calculate EK final by multiplying this by 2, which is 27,216 joules. Now that we have the final kinetic energy, we can rearrange the kinetic energy equation for velocity. Here's how you rearrange it. Half mv squared equals EK. We multiply both sides by 2. Then we divide both sides by m. And then we take the square root of both sides. So then v is equal to the square root of 2ek over m. You should have this equation rearranged for v written down on your cheat sheet because it's pretty common to use it. And it's a little bit more difficult to rearrange. If we substitute the numbers, then v equals the square root of 2 times 27,216 over 84. Let's put this into the calculator. Press the square root button, then the fraction button, then 2 times 27,216, then arrow right or down to get to the denominator, and enter 84. We should get an answer of 25.455, which can be rounded to 2 significant figures, so the answer is 25 meters per second. Notice that the increase in velocity is not double the initial velocity, even though the kinetic energy has doubled. This is because velocity is proportional to the square root of kinetic energy. The beauty of understanding proportionality is because you can solve equations so much faster. If you multiply the initial velocity of 18 meters per second by the square root of 2, since the kinetic energy has doubled, you would get the same answer, but much more quickly. Let's demonstrate that in the calculator. 18 times the square root of 2. That gives us the same answer of 25. Amazing! Isn't maths and physics cool? I absolutely love it. Question 4. A child pushes a 15 kilogram rock a distance of 10 meters while applying a constant horizontal force of 30 newtons on the rock. How much work did the child do on the rock in joules? Mass, or m, is 15 kilograms. Distance, aka displacement, is d, which is equal to 10 meters. Force, or F, is equal to 30 newtons. We need to find work, so W equals question mark in joules. The equation for work is force times distance, or W equals Fd. You can see that the mass of the rock is not required. Let's substitute our values into the equation. Work equals 30 times 10. If we put that into the calculator, 30 times 10, we get an answer of 300 joules. This is the amount of energy that the child transferred to the rock. Question 5. A child pushes a 15 kilogram rock a distance of 10 meters while applying a constant horizontal force of 30 newtons on the rock. If all of the work done on the rock is converted into kinetic energy, what is the final velocity of the rock in meters per second? This is the same question stem as the previous, so we know that work is equal to 300 joules. And all of the work is converted into kinetic energy, so EK is also equal to 300 joules. We have been asked to find the velocity of the rock, so final velocity equals question mark in meters per second. We can use the kinetic energy equation rearranged for velocity. So V equals square root of 2 times kinetic energy over mass. If we put the values in, then V equals square root of 2 times 300 over 15. Putting it into the calculator, press the square root button, then the fraction button, then 2 times 300, arrow right or down, then 15 and enter. We get an answer of 6.3 meters per second, rounded to two significant figures. Question 6. A child pushes a 15 kilogram rock a distance of 10 meters while applying a constant horizontal force of 30 newtons on the rock. If the rock starts from rest and 50% of the work is lost due to friction and only 50% is converted into kinetic energy, what is the final velocity of the rock in meters per second? Again, we know that work is equal to 300 joules because the numbers haven't changed. But this time, kinetic energy is only equal to half of work. So EK will equal 0.5 times work, which is 0.5 times 300. So EK is equal to 150 joules. We want to find the final velocity of the rock. The V equals question mark in meters per second. Again, we can use the equation for kinetic energy rearranged for velocity. The V equals square root of 2 times kinetic energy over mass. If we put the values in, then V equals square root of 2 times 150 over 15. So putting that into the calculator, we get an answer of 4.5 meters per second, rounded to two significant figures. You may remember that velocity is proportional to the square root of kinetic energy, and since our kinetic energy has halved, we could have multiplied our previous velocity by the square root of 0.5 to get the same answer. So 6.3246 times the square root of 0.5 gives us a new velocity of 4.5, rounded to two significant figures. Question 7. A man pulls a golf trolley behind him along horizontal ground. He exerts a 75 Newton force on the golf trolley that is angled 20 degrees from horizontal, or 80 meters. What is the work done on the golf trolley by the man in joules? Force equals 75 newtons. This is exerted at an angle of 20 degrees from horizontal. Since the direction of travel of the golf trolley is horizontal, we are only interested in the horizontal component of this force. So we need to calculate this using trigonometry. Here is the force vector, has a magnitude of 75 newtons, and an angle of 20 degrees from the horizontal line. If we turn this into a right-angled triangle, we want to find the length of the horizontal side. The longest side is the hypotenuse, and the side we want to find is adjacent to the known angle. So we need the SOHCAHTOA equation that contains A and H. That would be CAH. Cosine of theta equals adjacent over hypotenuse. We want to find adjacent, so multiply both sides by hypotenuse, get adjacent on its own. Adjacent equals hypotenuse times the cosine of theta. If we substitute our values, it's 70 times cosine of 20. So the horizontal component of the force is equal to 70.477 newtons, rounded to 5 significant figures. Distance is equal to 80 meters. We want to find work, so W equals question mark in joules. The equation that we'll use here is work equals force times distance. If we put in the numbers 70.477 times 80, then we get an answer of 5,638. And if we round it to two significant figures, then the answer is 5,600 joules. Question 8. A 15 kilogram child starts from rest and goes down a frictionless water slide that is a 10-meter long spiral. The difference in height between the start and end of the slide is 3.2 meters. What is the velocity of the child at the bottom of the slide in meters per second? The mass m equals 15 kilograms. The child starts at rest, so initial velocity vi is 0 meters per second. Distance, or d, equals 10 meters. Height, or vertical distance, represented by the letter h, equals 3.2 meters. We want to find final velocity, so Vf equals question mark in meters per second. We have the variables m and h, so we could calculate the potential energy. The child starts at a height, so they have potential energy at the top of the slide. When the child goes down the slide, gravity will do work on the child, and the potential energy will be converted into kinetic energy. The key word in this problem is frictionless. That means that no energy is lost to friction. So potential energy at the top of the slide will equal kinetic energy at the bottom of the slide. So EK equals EP. Now we could use the potential energy equation to calculate the potential energy, then use that in the kinetic energy equation, calculate the velocity. But that is unnecessary because I have combined these two equations. When potential energy is equal to kinetic energy, which means no energy is lost to friction, then velocity will equal the square root of 2 times gravity times height. Let's put the numbers in. Velocity equals square root of 2 times 10 times 3.2. If we put that into the calculator, press the square root button, then 2 times 10 times 3.2, that gives us an answer of 8 meters per second. You can see that we don't even need to know the mass of the object. Question 9. A block slides down a frictionless incline at an angle of 30 degrees below horizontal. If the block starts from rest, what will be its speed after sliding 5 meters down the incline? Meters per second. We know that the initial velocity is 0, so Vi equals 0 meters per second. There is an angle of 30 degrees and the distance is 5 meters. We have been asked to find the final velocity, so Vf equals question mark in meters per second. Basically, this is the same as our previous question. The block has potential energy at the top of the incline, and this is converted into kinetic energy as it goes down the incline. There is no friction, so potential energy equals kinetic energy. We can calculate the height by using trigonometry with SOHCAHTOA. Let's turn this into a right angle triangle. The longest side is the hypotenuse, and we want to find the length of the side opposite the angle. So we need the equation containing O and H. That would be so. Sine of theta equals opposite over hypotenuse. We need opposite, so multiply both sides by hypotenuse, get opposite equals hypotenuse times sine of theta. If we substitute our values, opposite equals 5 times sine of 30, and plug that into the calculator, we get an answer of 2.5. So height is equal to 2.5 meters. Now we can use the same equation as before to find the final velocity using height. V is equal to the square root of 2 times g times h. We put in the numbers, square root of 2 times 10 times 2.5, then we get an answer of 7.1 meters per second, rounded to 2 significant figures. Question 10. What is the minimum power needed to accelerate a 900 kilogram car from rest to a speed of 15 meters per second, 1 minute on a flat road, in kilowatts? Mass is 900 kilograms, and initial velocity, or Vi, is equal to 0 meters per second. The final velocity, Vf, is 15 meters per second. Time, or T, is 1 minute. We need to convert this into seconds, so multiply by 60, get time is equal to 60 seconds. We have been asked to find the minimum power in kilowatts, so P equals question mark in kilowatts. Power is a measure of the rate of energy used per unit of time, so the units are joules per second. Instead of saying joules per second, you can say watts instead. What? The equation for power is P equals energy over time, or E over T. We have velocity and mass, so we can calculate the kinetic energy gained by the car when it reaches its final velocity after starting from rest. Because E equals EK, we can replace E in the power equation with half mv squared. So P equals half mv squared over T. Putting the numbers in, P equals 0.5 times 900 times 15 squared over 60. If we put that into the calculator, press the fraction button, enter 0.5 times 900 times 15 squared, then arrow down and 60 and enter. Press the SD button to convert into a decimal number and we get 1687.5 joules. We need this to be in kilojoules, so we need to add the kilo prefix. To do this, we divide by 10 to the power of 3, which makes it 1.7 kilojoules. So that's it for mechanical energy. Try solving these problems on your own to see if you remember how to do them. If you get stuck, you can refer back to my videos. The next section will be on centripetal force. See you in the next video.